Okay, so now we will talk about the ARIMA model. ARIMA model is basically combination of two models, autoregression and moving average, and the middle term is called integration. So I will talk about the integration later. First we will see AR. AR is autoregression. So what is autoregression? It basically a regression model builds based on the lags. So yt minus 1, yt minus 2 up to yt minus p, we are making a linear combination of a series lag, series itself lags, and then we are trying to predict the current time series value, right? So this become a regression, linear regression model which whose predictors are its lag only, right? So now here the p becomes a parameters to decide up to what lag we want to build a regression model, AR model, right? So now p we have to decide, so lag 1, lag 2, lag up to p. And we have some coefficients on the lags, and alpha is the constant, and then adding error terms, right? Okay, now next is the moving average. Moving average model is also a regression model actually, and here the predictors like independent variables like we use in a linear regression, we have like y equals to m1 w1 plus m2 w2 plus so on and beta, right? Something like this. So the predictors x1 x2 y equals to w1 x1 plus w2 x2 plus and so on, and let's say beta 0 or something, w 0 or constant b we apply. So similarly here these are errors, and now you have to understand what exactly these errors are. These errors are basically the error when we are making a regression model, and then how much difference it is from actual. So if I say et, so et is the difference of e at t and e at t minus 1. Okay, so you can see how the this is made. So then we combine both auto regression and integration, and we combine and make a final model which is also a linear model having combination of um, auto regression model and moving average model which is coming from this, right? So you can see the last ARIMA model is some constant and linear combination of lag of y, right, up to p, the parameter we try to find the base parameter, right? And then the linear combination of lagged forecast error. So lagged forecast error is the important thing we have to understand. This built on the errors, which is basically forecast error. Okay, now the integrated, what it means, and we have a parameter called d. D is the number of difference. Okay, so how, what it means is, so let's say we have a time series which is non-stationary. So to make it stationary, how many times we have to difference the series to make it stationary? So this is very popular question, why the stationarity in time series ARIMA model needed. So I have very simple answer. I have written it very simple way. So you can see the ARIMA model is just a combination of two regression models, like auto regression models and moving average models. So if you remember, a regression model have assumption that the predictor of its are not correlated, like we have y equals to x1 beta 1 plus x2 beta 2 plus beta 0. So x1 and x2 should not be correlated, correct? So this is the assumption of linear regression model. So same thing applies here. As you can see, the predictor x1 x2 here are the lag. Lag is nothing, just the previous values of a series. So what it means, it should not be correlated, means the previous values of a series at any lag, like lag 1 lag 2 lag 3, they should not be correlated, right? So this is our assumption. So how we can satisfy this assumption here is making series non-stationary. So when we make it non-stationary, the assumptions will be satisfied. And how the assumptions will satisfy by making series non-stationary, I will show you an example. Let's say this is our series, and this is, if this is the series, you can see there is a trend, and when there is a trend, the series is non-stationary. Okay, so here you will see, let's say this is y previous, y next. So all these values are correlated. Correlated means these, they have some combination, and they have some relations. You can see, if I have to get this value, maybe I can multiply, add some numbers here, and I can get this. Similarly, if I have to make at this point, I can multiply or add something here, and I can get this. So it means if the series is stationary, uh, there will be some correlation. That is why we have to make it non-stationary, right? So how to make it non-stationary, how many order of differencing required in the model, this I will talk about in the next video.